All right, hello everyone. We are now on section 9.3. We've done one whole chapter, chapter 8, on hypothesis testing of proportions. And now in chapter 9, we did hypothesis tests and confidence interval for mean. And one of the conditions for the ones we've been doing is that we knew the population standard deviation. I think I had mentioned in class, or maybe in homework or something, I'm not sure where, that in most real world problems, we're never going to know the population standard deviation. It's just unrealistic. Remember, if you know the population standard deviation, you pretty much know the population mean, because where did that standard deviation come from? Well, it came from a formula with mean in it, right? And then if you knew the population mean, you wouldn't be doing any hypothesis testing or confidence intervals. So realistically speaking, the real we don't know what that standard deviation is. So what do we do if we don't know it? So we have another test, another distribution. It's called the t-test or t-distribution. So what we're going to do is very simple, is we're going to estimate the population standard deviation. We're not going to just guess, however. What we're going to do is we're going to use the standard deviation of our sample as a prediction or an estimate of the population standard deviation, put it in the formula. The problem is, if we do this, mathematicians have learned over doing millions and millions of samples that the sample standard deviation tends to be smaller than the population standard deviation. So we need to adjust. So what we've been calling Z star, we're going to take that Z star, we're going to make it a little bit bigger. And something happened with my formatting there, sorry. And we're going to use another number. It's going to be a little bit bigger, and it's called a T star. So this is called a T distribution instead of a Z distribution. The value of that T star comes from a chart that's very similar to the one we use for Z star. That chart is in your note sheet. I'll show you real quickly here. Give me a second to pop over here. If you look at your note sheet, on the first one, the first 2 pages of the note sheet, this is also in the back of your book also, we had the tables for the normal curve and those z-stars, which we stopped using right at some point because we used the calculator, which I'll show you also how to do this on your calculator. But here's the chart for a t-distribution. All right, the t-distribution chart, if you're going to use the chart, and most of us will go away from this chart really quickly, so it's not a huge big deal if you know how to use the chart. First of all, it works a little differently. Notice that the area is over here on the right. All right, it's on the right. So what you have here, it's a little different chart because on the Z distribution chart, you had your Z scores here and here for hundreds and thousands, and then the areas were here. Here it's backwards. The areas are up here at the top, 25%, 20%, 15%, 10%, 5%, 2.5%, and so on. It's the right tail probability. And then these are the numbers that go along with it. This on the left-hand side are called degrees of freedom. So the number changes based on how many people are in your sample. Okay. The bigger the sample, the closer this number will be to being really what Z is. And by the way, if you look down the bottom, let's say if we take that 2.5% tail probability, which is our 95% number, and we scroll down to the bottom, 95%, here are your confidence levels. Notice the 1.96 when we get to infinity. It's getting closer and closer to 1.96. Okay. So these are what are called degrees of freedom. I'll tell you what that means in just a second. Degrees of freedom are related to your sample size. So I'll be bouncing back and forth between this and the paper. I apologize, I won't be able to show you anything on the calculator because I can't bounce back and forth, so it might be a little bit tricky. But I'll just talk you through it. If you have your calculator, it should be fine. All right, so degrees of freedom I just mentioned. Degrees of freedom, what you're looking for, is the sample size. N is the sample size, so the sample size minus 1. Okay. Our calculator can do this work for us also, but the chart's pretty helpful at the beginning. So basically what I'm going to do is just walk you through an example problem. We're going to do a hypothesis test and a confidence interval. And it's very straightforward. It's going to feel pretty much what we've been doing. We just have to make some minor changes. So let me do a little bit of covering up here. Sorry, I should have done this before. All right, we don't need those numbers here for now. All right, so this is called a hypothesis test for mean. when you don't know the population standard deviation. Okay, so we're going to do a hypothesis or a confidence interval. If you look in your calculator, it's actually called a t-test instead of a z-test. So we've been doing z-test for knowing the population standard deviation, t-test for not knowing. All right. So all you have to do, it's very simple, is we're going to take the same formulas we did before, and we're going to take our sigma, our standard deviation of the population, and replace it with our S. All right, so all we have to do is replace S for sample standard deviation, for population standard deviation, and T star for Z star. Everything else is going to work the same. And I'll kind of walk you through it on the calculator. So here's the problem. Someone thinks that the Earth is actually less than 93 million miles from the sun. If you didn't know, that's what we think it is, 93 million miles. All right, and we're going to do a hypothesis test to test this. So there's two different ways this can happen. So I actually gave you the numbers here. So if you notice down here, these are the actual measurements. No, they're not all of them. There's more of them. Maybe I lost some of them. 1, 2, 3, 4, 5, 6, 7, 8. I don't know. Don't worry about the measurements. So either you can be given just the number. Sometimes you're given a list, so you have to put the numbers into a list, which I'll show you in a second. But other times they just give me the data. So if you notice, my average was 92.93, and my standard deviation was 0.112. That was in 15 different measurements. And let's just, for fun, do a test with a 10%. So let's walk through the steps here. So first thing we do is we name it. It's called a t-test. Still need simple random samples, so we're just going to assume that was done. This one, the standard deviation is unknown. All right. And then like before, population, at least 10 times the sample. Not an important thing here. We could be taking millions of these samples, at least 10 times the sample. All right. So I'm going to do this kind of shortcut a little bit. My mean, my hypothesis is going to be the mean is 93 per million. I'm just going to, normally I would write that out, right? The alternate is we believe it's less than 93 million. So now we're going to find our test statistic. It's now going to be called T instead of Z. We're going to find it exactly the same way we would have, which would be what we got, which is 92.93. minus what we expected to get, which was 93, all over the standard deviation, not of the population, now of the sample, which is 0.112, divided by the square root of the sample size. I'm going to do a little bit of math here. Give me a second. 92.93 minus 93, 0.112 divided by square root of 15. And I got a test statistic of negative 2.42. We need a little picture. So we need that T star now, right? T star instead of Z star. It's a one-tailed test, so all my alpha is going over here. So I have two ways to do this. So I'm going to kind of walk you through it on the calculator right now. I know you can't see the calculator. Or you could just go to your charts. So let me just show you on the chart. So we had 15 was my sample size. Let me just show you how this works. We want to use the chart first. 15 was the sample size, which means my degrees of freedom is 14. Our tail probability was all 10% on the right-hand side. So 10% on the right-hand side. So you can see 1.345. We're on the negative side, so that would actually be negative 1.345. Okay. So that's using the chart. Let me go back. Negative 1.345. We're definitely in the, so notice that had moved from where it would have been if all 10% would have been over there, which would be 1.645, right? All right. You can also find that on your calculator. So if this were a normal problem, you would have done inverse norm of 10%, right? But now you can go, I'm just going to walk you through. Sorry, you can't see the calculator. I'm going to distribution. Whoops. Distribution. Instead of inverse norm, we're going to go to inverse T. It's right underneath it. Inverse T is going to ask for the area, which is 10%. It's going to ask for the degrees of freedom, which is 14. And then we can click it on there and we get negative 1.345. Okay. P-value works the same way as it did before. Notice this is the only thing I did different right there so far was the T star, right? Nothing else has been different. I can find a P-value. Normally to find a P-value, we want to find, remember, let me change colors here for you, P-value, negative 2.42. That would be the P-value, right? But instead of inverse norm, instead of normal CDF from negative infinity to negative 2.42, that's what we would have done. We're going to do inverse or TCDF. So if we go to distribution and you go couple under inverse T is TCDF. So it's important whether you're doing T or Z. We're going to go lower as negative infinity, upper as negative 2.42. So let me write this out for you here. P equals TCDF from negative infinity to negative 2.42. And then it needs the degrees of freedom again, which is 14. And we get a p-value of 1.48%. So notice all my processes are the same. The only thing different is I'm using the TCDF and the inverse T on my calculator. So I'm not going to write the rest up. Clearly, we're going to reject the null hypothesis. And there is evidence that the distance to Earth is less than 93 million miles. Same exact process, like I set up here. All you got to do right here is replace S for your replace your sample standard deviation with your population standard deviation and a T star for a Z star, and then call it T instead of calling it Z. It works the same in a confidence interval. Oh, by the way, I could have done the whole test on my calculator. Okay. Remember, we've now learned how to do this on your calculator. So that little process there. So I'm just going to walk through that again. I know you can't see it. Sorry. We'll do it in class too. So now I'm just going to stat tests. This is now a t-test instead of a z-test. It's the next one down. T-test. If you hit t-test, notice it's going to ask for data or statistics. All right. Statistics are what we have here. We have the mean, we have the standard deviation. If all you have is a list of numbers, like the actual measurements, you put those measurements into a list, those numbers, which I'm going to do in the next example so you can see it. And then you say data. If you scroll your calculator over to data and hit enter, you notice that it's just going to ask for a list instead of the mean and the standard deviation. If I go back to stats and hit enter, now it needs the mean and the standard deviation. So I'm going to do stats. The first thing it asks for is my hypothesis, which is 93. Then it asks for the sample standard or the sample mean, which was 92.93. Then it asks for the sample standard deviation, which is 0.112. Then it asks for the sample size, which is 15. And then it asks for left-tailed, right-tailed, or two-tailed. So we're going to go left-tailed. We're going to hit calculate, and we'll see the same numbers. P-value, a test statistic of negative 2.42, and a p-value of 1.48%. We'll walk through that in class again also. But you can do it on your calculator instead of with the formula. Formula is still important, though, because I can ask questions that make you use that formula. So now what I'm going to do, one last question. We'll do a confidence interval, a different problem, and a data. So this is, ignore this last question here. I'm not going to ask that. So we're just going to do a 92% confidence interval for this. We'll just say these are average quiz scores or something. It doesn't really matter what. So I've already typed these numbers in my calculator. They're sitting in there as list one. So if I was doing this without my calculator, just so you can see it, right now they're in my list. So now I would have to do one variable statistics on list one to get the important information. So this actually had a mean of 5.019 and a standard deviation of 1.1. That just comes for one variable statistic. I don't really need to find those because I can do this all completely on my calculator, but just as a little review. And then if I wanted to do the 90% confidence interval, it'd be 5.019 plus or minus. So now I need that confidence level for 92%, which is a leftover 8%. So remember, this is inverse T now, inverse T of 0.04, and we would need the degrees of freedom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 9 degrees of freedom. All right, so if I go inverse T of 0.04 with 9 degrees of freedom, I get 1.97-ish. And then we multiply that by the standard deviation of the sample, which is my t now this time, which is the 1.1 divided by the square root of the sample size, which was 10. So there's my interval written by hand, but I can also do it right on my calculator. So I could go right to stat, calculate, stat tests, and we're going to scroll down. This is now a t interval because what's the difference between z and t? It's very simple. Do I know the population standard deviation or not? Nowhere in this problem was I given it. So the t interval, this time we have data instead of stats. So I'm going to scroll over to data, hit enter. It's going to ask me for my list, which is list 1. Then it's just going to ask me for frequencies, leave that alone. And then confidence level was, if I can find it, 0.92, right? And then we just hit calculate. It's going to do all the math for me. It's going to tell me the endpoints 4.33 to 5.7. So the t is very simple. We're going to start seeing the same things. Hopefully we're getting used to the process now. Everything works the same except for you just replace your z with your t, and your sample standard deviation replaces the population standard deviation.